Hello everybody. Sorry I'm not at school today. I plan on being back tomorrow. My youngest daughter is just home from school sick. So I hope you have already taken some time to complete the properties of quadrilaterals chart with a partner or some people around you. I hope you took some time to really think about it as you were filling it in without looking at your notes, or maybe minimally looking at your notes, and then checking with mine when you were finished. So anyway, it's just another organizer for you. Now I think we're up to 3 or 4 organizers of these properties, and I hope that they're starting to kind of sink in, you're remembering them. Use whichever organizer seems to work best for you. Okay, so now let's work on some always, sometimes, nevers. It's a good idea if you pause the video and you try these yourself and then come back and we'll go through them. Okay, welcome back. So, always, sometimes, never. A square is a rhombus. Well, since a square is at the bottom of our flow chart, it is always a rhombus. A trapezoid is a kite. That's never. The only way to get from trapezoid over to kite is to go up and then down, so that's a never. The diagonals of a kite bisect each other. Well, a kite itself, I mean just a plain kite, only one diagonal bisects the other. So if the diagonals bisect each other, that's going to be a sometimes when it's the next figure down, which is a rhombus. The diagonals of a trapezoid are perpendicular. No. Not even as an isosceles trapezoid. Those are not perpendicular. So the diagonals of a rectangle bisect the vertex angles. Well, the rectangle itself, that's not true. Right, so I'm thinking, or maybe the next figure down or over, right? Would that happen in a rhombus? That would happen in a rhombus, but the rectangle is not connected to the rhombus, so the next figure would be the square. All right, so part E, I don't know how to fix the wording on that, but there are 2 ways that you could be reading this. If you're reading this as the upper is congruent to an upper and lower congruent to lower, if that's the way you're reading it, then I would say that this is a sometimes, not just a trapezoid, but an isosceles trapezoid. If you were reading that as upper being congruent to lower, well, that never happens in a trapezoid. That would happen in, say, a rectangle, right? And a rectangle is not a trapezoid, so that would be a never. Okay, so that depends on how you read that one. All right, so now for the proof. This is a good proof. I really like this one. We have 2 parallelograms that are sort of somewhat overlapping. I'm just going to trace them out. We have this first parallelogram, and then we have this second parallelogram. See those? All right. So our goal, our target, is to prove that triangle EAB is congruent to triangle DEC. Yep, those are our targets. So I'd like for you to pause the video and think about this a little bit in terms of a plan. Think about how you would approach this proof. and then even try the proof. And when you are ready, you can come back to the video. Okay, welcome back. So when I look at what I have and where I'm trying to go, what I know and what I want to know, I'm thinking about how would I prove these two triangles congruent? Well, I've already got some information from my green parallelogram. I think I can get sides of my triangle. And I'm going to just sort of mark this up, and then I'm going to go back to my proof. I could get this side congruent to this side from the green parallelogram, right? And that right there, that's sides of the triangles. Now, in the green parallelogram, I could also get these sides to these sides, right? And do you see that BC is overlapping in the two parallelograms, right? So I can also, for the yellow parallelogram, get the opposite sides congruent. And if that's true, then I have a transitive so that I could get AE and ED congruent as sides of the triangle. You see that? So right now I have two sides. I think from the yellow triangle, from the yellow parallelogram, I can also get these sides congruent, as those are opposite sides. So I think I can prove these two triangles by side, side, side. Yeah? Now, if we were going to pause and just sort of think flexibly on this one, there's another way to do that. And that is, if you see the these parallel sides and this transversal, do you see the F? We could get these two angles as corresponding angles. So I could also do this by side angle side, which is a nice way to do it as well. I think, though, that the most efficient method is actually side, side, side for this proof, but I think it's really cool to do this one by side angle side. So as far as which one's better, I don't know. I mean, efficiency versus kind of cool. I don't know. I think they're equal. So I'm actually going to do this one by side, side, side. But man, it's cool to do by side angle side. Anyway, I'm going to do this one by side, 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 because I think that's a more likely way that you would see it. But anyway, okay, so let me erase a few things so that the diagram's not as crowded. All right, so I'm going to start with my givens. I'm going to list them both. All right, now I think I'm just going to start doing those opposite sides. I've got AB congruent to EC. That was from the green parallelogram. And I also get AE congruent to BC. That's in the green. Additionally, I get, and I'm going to write this over here so that you can kind of see the transitive, I get ED congruent to BC. So now you can see the transitive link. And I also am going to write the third pair, which is EB to DC. All right, so the first two listed were from the green parallelogram, and the second two listed were for the yellow parallelogram. And the reason that I could list them all the same is that the reason or the justification is the same, and that is in a parallelogram, the opposite sides are congruent. So now I'm going to do the transitive link, which is this one here, right? See that link? So now I can say that AE is congruent to ED, the transitive property. And so now the two triangles are congruent. All right. Seem good? Right? Okay. I'm almost tempted to do that one the other way. I'll come back to it. Tell you what, that'll be like a bonus, right? At the end of the video, I'll come back and I'll do that one again by, instead of side, 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 I'll do it by side, angle, side. All right, in the meantime, let's take a look at our next one. Now we have a rectangle, and our job is to prove, so our target is to prove that triangle RCT is congruent to triangle ETC. Ooh, overlapping triangles. All right, as soon as I see the overlapping triangles, I'm already thinking, I've got this. Yeah, I've got that reflexive side. What else do I know about a rectangle? I know that these are right angles. And I also know that in a rectangle that opposite sides are congruent. So I could do this by side, angle, side, right? But again, I want to encourage you to think flexibly. Because there are lots of ways that you can do this. I could also, I think, do RHL, right? Instead of doing the opposite sides congruent, I could use the reflexive side, the right, and I could say that the diagonals are congruent. Because in a rectangle, aren't the diagonals congruent, right? So I have choices. I could do side, angle, side. I could do RHL. I bet we could even come up with more. We could do side, 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 right? Because we could use these opposite sides. We could forget the right angles. We could use the diagonals, right? So we've got lots of ways that we can do this proof. You just need to think about which one you would prefer to use. I think I'm actually going to go, which way do I, well, the last one I did was side, side, side. So how about if I do RHL in this one, right? But thinking flexibly, remember, there are many, many ways you can do this. So I'll start with, I'm going to shoot for RHL. I'm going to start with the given. And then I'm going to use my reflexive side. Actually, no, I'm not going to do that right away. That doesn't really flow too well from the fact that it's a rectangle. I'll use that. I'll put that in last. So what did I say? RHL. So I'm going to start with angle RTC and angle ECT are right angles. Because in a rectangle, all the angles are right angles. And then I'm going to go RT congruent to EC, because in a rectangle, opposite sides are congruent. That's true because a rectangle is a parallelogram, right? And a rectangle has all the properties of a parallelogram. Okay. Oops, not 3, 4. So now I've got the right angles. I've got the opposite sides. Sorry, I just had to type something in for my daughter. Okay, next I need the reflexive side. So TC is congruent to CT. Watch your correspondence, right? You see these overlapping, there's that reflection. This is reflexive. So what do I have? I have right, I have, oh shoot. That's not setting it up for RHL. I'm actually kind of going more towards side angle side, but I'm not really doing well for side angle side either, because if I was going to use side angle side, I'd need my step 3 to actually be that the two angles are congruent to each other. All right, so let me change step 3. Sorry about that, I'll just cross it out. And I'll say that instead of the sides, I'm going to say RC is congruent to ET, because in a rectangle, the diagonals are congruent. You see the change I made? I know why I did that too. It's because I still had this marked on my diagram. Right? I still had those sides marked. Okay, so I think I'm ready. Triangle RCT congruent to triangle ETC by RHL. Let's double check it. I got my rights in step 2. I got the hypotenuse, that's the diagonals, in step 3, and I have my leg in step 4. Done. Okay? So, but remember, just to reiterate, you could do this one by side angle side if you had, instead of crossing out what I crossed out in purple, step 3, you could have used that, but you would also have to say between steps 2 and my step 3 that the two right angles are congruent angles in order to use side angle side. Or you could skip the angles entirely and do the reflexive and the opposite sides and the diagonals, and use side, side, side. So, all right, last one is a set up and prove. All right, so if a parallelogram with 4 congruent angles is a rectangle, then the diagonals are congruent. All right, so if a parallelogram with 4, so this whole statement, this whole piece is the if, right? So we're given all of this. So we know it's a rectangle. But what we know about the rectangle and what we're supposed to use is the 4 congruent angles. All right, so let's draw our diagram like so. I'm going to label it A, B, C, D. Then the diagonals are congruent, so that means I need to draw in my diagonals. All right, and what I know about this is that I'm actually given that it's a parallelogram with 4 congruent angles. Right? So if it's a parallelogram with 4 congruent angles, then the diagonals are congruent. This seems sort of extraneous, right? Because I don't want to say, what I'm trying to get at is that it's not, sure, I mean a rectangle, if it's a rectangle, then the diagonals are congruent, of course, right? But it's part of that sort of if it's a rectangle, right? So we're starting with first, if it's a parallelogram with 4 congruent angles, is that enough to say then that the diagonals are congruent. So we're trying to prove one of the properties of a rectangle. All right, so given that we have parallelogram A, B, C, D with 4 congruent angles. All right, so angle A, B, C congruent to angle B, C, D congruent to angle C, D, A congruent to angle, let's see, I got A, B, C, I got B, C, D, I get C, D, A, now I need D, A, B. Then we want to prove that the diagonals are congruent. So we would want to prove that AC congruent to BD. Right, so this seems pretty similar to the proof that we did above. The only thing is we can't use RHL in this one because we can't use AC and DB, right? We can't use the fact that this is a rectangle so much because we're trying to prove a property of a rectangle. So we want to kind of think about this as a parallelogram. But I do think that we could still prove these same overlapping triangles that we had in the proof just above, right? We could prove those same overlapping triangles, but just not use RHL. We could use our other two methods. We could use, well, not our other two. We could go by side angle side on this one, right? Okay, so I'm going to change colors so that it's clear that whatever marks I make on my diagram are not marks for my setup, but they're marks for my proof. So how about pink? No, purple. All right, I'm going to start with the parallelogram. All right, now my plan for this is I'm going to do these, all right, from the parallelogram. So I'm going to say AD is congruent to BC because in a parallelogram, the opposite sides are congruent. And I think that's all I need from the parallelogram, because I'm going to go for my reflexive, and I'm going to use that these angles are congruent, right? That I had all 4 of these angles. I don't need the top ones, but so I'm actually going to back out of those because I don't need them, but that was part of it. So I'll use my other given and say that angle ADC is congruent to angle, let's see how it was named, hold on. It was named angle CDA, so I have to name it the same way. In the given, CDA I suppose I didn't name them very well in the givens, did I? I didn't name them where I was setting myself up for correspondence. Because if I name that one CDA, then the other one should be named DCB. Okay, well this is an easy fix, right? Because I'm the one who set it up, so I can easily change that. So I'm going to go back and let's see the one with the, I'm just going to go with this and call that angle DCB instead. All right. All right, so this was given. And then I have my reflexive. Watch the correspondence because of the reflection again. And so I have triangle ADC congruent to triangle BCD by side angle side. Let's just make sure I've got a side in step 2, angle in step 3, side and angle in step 4. And then I should be able to get the diagonals by CPCTC. Okay? All right, so a little review in that too, where we have the missing diagram. All right, so at this point, you can stop. You can move on and start working on your homework if there's time left. Or you could, if you're interested, well, I'll go back in the video at this point to the first proof on the note sheet. So you don't have to stay with me at this point, but if you're interested, I'm going to go back and I'm going to do that proof again by side angle side. All right, so I think what I'll do is I want to leave this here and just alternatively do a different proof, right? So I'll change colors and everything here. Let's do sort of pink. So if I was going to do this by, instead of side, 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 if I was going to do this by side, angle, side, what would I do differently? I would have my same givens, listing them first. I still need my transitive hook, right? Because I need my two sides. So I'm going to need AB congruent to EC. I need that. That's one of my sides. And I need AE to BC. And I need ED to BC. Now, I know that seems weird that I wrote it over there, but what I don't need is that fourth side. I just need this for the transitive. And this is all right. So what I have now is I have two sides. I have this side. How do I want to mark that? Let's do it this way. I have this side, and I have this side that I can now get through transitive. All right? Okay. It's confusing to have all those marks on the diagram. Now remember, if I'm going to use side, angle, side, I needed this right? I need that if I'm going to use side, angle, side. So I'm going to have to say also from the parallelograms that AB is parallel to EC. Well, that's true in a parallelogram. Opposite sides are parallel. Then I can get angle A is congruent to angle CED. Notice that I can't name this angle angle E because there are lots of choices for angle E. But I could name the other one angle A because there's only one choice for angle A. Yep. If we have parallel lines, then the corresponding angles are congruent. All right. Oh, sugar. I forgot my transitive. All right. Well, because I've got a computer, I can do this. I talked a lot about transitive, but it didn't actually do it. I need AE congruent to ED. All right, so now I have it. Now I have Side, angle, side. So triangle EAB, congruent to triangle DEC, by side, angle, side. Let's see, I got my first side in step 2. I got my angle in step 5. And I got my other side in the transitive, which was in step 3. Okay? So the second one, the second version, is kind of cool because I'm using more properties of the parallelograms. But I do think that the first method that we did by side, side, side was more efficient. Look, 4 steps versus 6 steps. Okay?